Hello everyone and welcome back. My name is Mr. Covalt, and in this video we're going to go over how to calculate the value of the equilibrium constant for a reaction. And also we're going to classify the reaction and determine whether or not the final concentrations should be determined by either treating this as an equilibrium problem or as a stoichiometry problem. So let's get into this. Okay, so in this problem we're asked to calculate the value of the equilibrium constant for the following reaction. So we have NO2 minus, the nitrite ion, reacting with H3O plus, the hydronium ion, to produce HNO2 and H2O. And so we're asked to determine or to classify this reaction and also to determine whether or not the final concentrations can be found by treating this as an equilibrium problem or as a stoichiometry problem. So the first thing you want to do is notice here that the reaction here is actually the reverse of a reaction of a weak acid with water. So notice here that we have a weak acid, the nitrous acid here, and water as products. So if we were to go this way, we would have the weak acid reacting with water to produce the hydronium ion and the nitrite ion. So if we write our equation in the reverse direction, we get HNO2 plus H2O in equilibrium with NO2 minus plus H3O plus. Okay, so now we have it written as a weak acid reacting with water to form products. And so that helps us out here because this fits the definition of a Ka value. So we can find the Ka value of this reaction. The Ka value is associated with any weak acid that reacts with water. And so for this weak acid, the nitrous acid reacting with water, we can actually look up that Ka value in a table somewhere. And when we look that up, we get 7.2 times 10 to the negative 4. So 7.2 times 10 to the negative 4. And so this is helpful because, like as I said, this is the reverse of this reaction. And if you remember anything about the relationships of your equilibrium constants with the reactions, we know that if you flip a reaction or if you reverse a reaction, then the Ka value for the new reaction is the reciprocal of the K value of the an old reaction. So here, if we treat this as our new, as the old reaction, and we know the Ka value, then if we flip it to get this one, then the K value for this one has to be the reciprocal of the Ka value of the one we flipped. So all we have to do is take 1 divided by the Ka value to get K. So then K, the equilibrium constant for this reaction, is equal to 1 over Ka, which is equal to 1 over the Ka value, which is 7.2 times 10 to the negative 4. And when we calculate that out, we get 1.38 times 10 to the third. Let me double check that. Yep, 1.38 times 10 to the third. And if we round that to 2 sig figs, we get 1.4 times 10 to the third. And that is how you get the Ka value for this reaction. Now, what about classifying this reaction? So you'll notice here we have NO2, right? So NO2 is the conjugate base of a weak acid, which makes this a weak base. And here, the hydronium ion If you have a hydronium ion written here, then that indicates that you are reacting with a strong acid. Because strong acids ionize completely in water, you only need to write down the H plus or the hydronium ion in your reaction. So this would be an acid-base reaction between a weak base and a strong acid. Now, what about treating this either as an equilibrium problem or as a stoichiometry problem in order to figure out what the final products are? And the answer would be that you would treat this as a stoichiometry problem. And the reason that I know that is because look at the K value that we calculated for that reaction. It is much, much greater than 1, right? So on the order of 1,000, 1,500. So that indicates that the reaction is going to be heavily favoring the products. And so at the end of the reaction, you're going to have a whole lot of products, and so very little of the reactants left. So this would be, you would treat this as a stoichiometry problem. So that's it for this video. I hope this was helpful. If this helped you in any way, if you enjoyed the video, then please by all means like the video, share the video, hit that like button over there somewhere. Also, subscribe to my channel, help me out. Hit the notification bell up above. When you do that, click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me. Sorry about that. Thanks for joining me and have a great day.